So here we have a question which is asked by one of the student. It is question number 13th of electromagnetic induction chapter of H.C. Verma. If you want, you can pause and read out the question. I'm going towards the solution. So here what is given here is like this is a rhombus kind of thing which is being pulled. So there is a hinge joint kind of thing at this point A and this point B, and also at the other two edges, vertices. Now this end is being pulled with a velocity u, and this end is being pulled with a velocity u, and so obviously this C will be coming down because this length L is constant and all other lengths are also constant, and this D will go up, but what will remain fixed is the intersection point of the diagonals. So this point O will remain fixed. So you can say that okay, this B is located at a distance of x from point O, and since O is fixed, so rate of change of x is u. Now let us say that this angle is theta, this angle is theta, this angle is also theta. So you can say that this x is equal to L cos theta. Now what is given is we have to find out the induced EMF in this loop ABCD. And induced EMF according to Faraday's law is equal to rate of change of flux. So this rate of change of flux is equal to rate of change of like B dot A, and it is given that this magnetic field is actually into the plane of the paper or this is screen. So you can say that okay, the flux will be equal to B into A. So B is a constant only, and this A is changing. A means the area, and the area is changing because A and B are pulled away from each other. Now what is the area? So area is 4 times the rectangle area. Now how much is this rectangle area? Oh sorry, triangle area actually. So this triangle area is half into base into height. So half into, you can say, L cos theta into L sin theta. Base is L cos theta, height is L sin theta. Half L square sin theta cos theta. So half L square sin theta cos theta. So this is the flux. So you can say that okay, this flux is equal to BL square by 4 sin 2 theta. Alright. So what is the rate of change of flux? Rate of change of flux is d phi by dt, which is equal to, if you differentiate, you will get BL square by 4 into d by dt of sin 2 theta. Now the derivative of sin 2 theta is cos 2 theta with respect to theta only when you differentiate. But here we are differentiating with respect to time, and so there will be additional term. Here you will write cos 2 theta into d by d theta of 2 theta. Alright, don't miss out on the 2. Sometimes we do that mistake stupidly. So we get BL square by 2 cos 2 theta into d theta by dt. Now this d theta by dt is not known to us, but this d theta by dt is the rate of change of theta here that depends on the pulling power or the pulling velocity. So we know that the rate at which x changes is dx by dt, and that dx by dt is u. So d by dt of x is L cos theta. Now that is given as u. So you can say that here we get L into minus sin theta into d theta by dt is equal to u. And so we get d theta by dt as u by L sin theta, alright, with a negative sign, u by L sin theta with a negative sign. So we will just use that value of d theta by dt and put it over here. So we get BL square by 2 into cos 2 theta into d theta by dt is u by, oh I forgot what it was, u by L sin theta with a negative sign. So this is the EMF, like magnitude of EMF. If you want, the EMF magnitude is equal to mod of d phi by dt, rate of change of flux mod value, so negative sign will go away. And so we get this BL square, oh sorry, BL only, BLU by 2 cos 2 theta by sin theta. And it is asked, okay, tell us the value of EMF induced at theta equal to like 60 degrees. So we will just put theta as 60 degree and get the values. B, U and L are constant. So this is how we do.